Hey guys, welcome. We're going to go ahead and jump into our 6-7 video. And this video has a lot of formula. Okay, so we're going to go ahead and jump right in. Now it's kind of hard to see. I'll go ahead and take that out real quick. But we have three formulas that are huge and critical for this. And it's distance formula, midpoint formula, and slope formula. Now we've actually talked about and used these. You've used these in other classes as well. But one of the best parts about this is when to use it. So distance formula we're going to use to determine if sides are congruent, diagonals are congruent. This can help us find different shapes. We're going to use midpoint formula to find if the coordinates of the midpoint of a side and if diagonals bisect each other. And then this next one, slope, we're going to use to see if opposite sides are parallel, diagonals are perpendicular. And then unfortunately it's kind of a little hard to read, but let's see if I can get out of here because I think how do I do this? Let me see, one second. I unfortunately, how do I make it stop? Oh, there we go. If we take a look, sorry, kind of smaller to see, but diagonals are perpendicular and sides are perpendicular. So make sure you guys write this down. This is hugely important to us. We're going to use these formulas to help us solve different parts. So let's go ahead and move to the next page. Okay, so we jumped right in. Here's our first example, problem 1. Is triangle ABC scalene, isosceles, or equilateral? So equilateral would be all sides are congruent. Isosceles would be two sides are congruent. And scalene would be all sides are different. Okay, so those are our three types of triangles that we could have. Now basically what we want to do is we want to check to see if side lengths are congruent. And what you kind of want to do in these ones is you want to look at the picture. And now normally I say don't go off what it looks like, but when it's in a graph and it's one that's done perfectly, like this one's on a perfectly separated graph, it's probably computer created, we actually want to look at it and take a guess what we think it is. Okay, so again, I don't know for sure, but I'm looking and I'm assuming, I'm guessing that A and B are going to be congruent here, and I'm thinking this is probably isosceles. I think AC looks longer, so that's going to be my assumption. Again, I'm going to go off of numbers still and facts, but having a good assumption helps us to kind of look what we're going for. So first I'm going to look at AB and AC. We're going to have to find them all anyways, so it's not a big deal. So AB is the first problem that we want to go ahead and solve. And it is helpful for me to put the points in. So B is 4, 4. C is going to be x of 7, 0. And this is going to be 0, 1. Okay. So I'm going to use this in the distance formula. So I need to find the distance of this. It's the square root of, okay, so if you guys recall from the notes of what we just took, it is going to be x1 minus y1, or sorry, x1 minus x2, or you could say x2 minus x1, doesn't really matter. But we're going from A to B, so we're going to do, I'm going to do A to B, so I'm going to go 0 minus 4, and then that's going to get squared, and then we're going to add, that's going, there we go, plus, and we're going to do the 1 minus 4. Okay? So here we go. And this is going to become negative 4 squared, which is 16. Negative 1 times 4 is negative 3, so negative 3 squared is 9. Add them together, we get 25. And conveniently, we know what the square root of 25 is. It is 5. Okay? So we got our work shown. AB is going to equal 5. I'm going to write up all of our information up here. AB is congruent to 5. Again, these just take time. We're not going to do a lot of these problems tomorrow. We're just going to take our time and go through a couple of these. Let's do our next one. And our next one is going to be AC. Now, I'm going to assume AC is probably not going to be congruent. That's what my thought is. And I'm thinking BC is probably going to be congruent, but I could be wrong. Who knows? So let's go ahead and take a look. D equals square root. Okay, I'm going to take A first and then go to C. So I'm going to do 0 minus 7. squared plus, and then we're going to do 1 minus 0 squared. Okay, so we're going to get 1 minus 0 squared, that's going to be 1. 7 squared is 49, and we get the square root of 50. Now this is okay, we don't have to actually rationalize this if we don't want to. I'm going to leave it. We could break this down, I might as well real quick. 5 times 10, and then 5 times 2. So I can actually pull out the 5. This is just basically simplifying radicals. So we get 5 rad 2 equals AC. Alright, cool. So we know automatically that we can't have a quadrilateral anymore because all the sides are not congruent. 5 is not the same as 5 rad 2. Okay? Even if we left it as rad 50, it would be the same. Let's take a look at our last one. This is BC. If this is congruent, then we're going to have isosceles, and that's what we get. So we know it's not equilateral anymore. Okay, so it could be isosceles or scaling. So we're going to go BC, and this is going to be the square root of, and I'm going to go B to C, so 4 minus 7 squared plus, and this is going to be 4 minus 0. As long as we keep it in the same order, it's going to be fine. 4 minus 7 is 3, 3 squared is 9, 4 squared is 16, which means I'm going to get 25. Square root of 25 is going to give me 5. So it looks like I was right in my assumption. BC equals 5. Okay, so my assumption has been verified. These are congruent. So our answer is isosceles. Okay, so 2 congruent sides, 1 non-congruent side. We were right. Okay, let's go ahead and move on to our next problem. Like I said, these just take a little while. We're not going to do a lot of them. They just take a little bit of time. Okay, all right, here we go. Is this a rhombus? So we're taking a look at this picture. There's a lot of things I could do to figure this out. One, I could measure all the sides, just like we did in that last one. And if all the sides are congruent, we could probably say it could be a rhombus or a square. 2, we could go ahead and see if AD and CD, what their slopes are. If they make a 90, we know it could be a square. But the best thing I could do is actually see what are 3 rules that are important only to a rhombus. Okay, so let's go ahead and take a look at what's true for a rhombus. Now, just looking at this picture, I already kind of know it's not a square. These angles aren't going to make 90 degrees. But looking at my rhombus rules, all sides are congruent, diagonals are perpendicular, and diagonals bisect. Well, actually, diagonals are perpendicular is probably the easiest thing I can do for this problem. So I'm going to go ahead and check to see if the diagonals are perpendicular. So we have 2 diagonals. We have diagonal BD. So what I'm going to do is I'm going to find the slope. And if I find the slope, I can relate the slopes. Remember, parallel slopes have the exact same slope. No matter how they move, they have the same slope. Perpendicular slopes are going to have opposite reciprocals. So let's go ahead and find the slope here. Okay, slope is going to be y2 minus y1. I'm only going to write this equation once for us up here. y2 minus y1 over x2 minus x1. And we're going to plug that in. I'm going to use b as my x1 and d is my y2. So d is y2, so we're going to get 2. I apologize, that is wrong. See, got to be careful. Again, all this is careful. Y2 is actually going to be 1 minus y1, which is 4, and then x2, which is 2, minus x1, which is 0. So this is going to be negative 3 over 2, and that's my slope. Okay, so here's my slope, negative 2 over 3. So if I'm going to get perpendicular diagonals, then I need to have 2 over 3 positive, right? That would be the opposite reciprocal. So let's see if we can get that. Let's change sky colors here. So let's go ahead and we're going to find the slope, this time of AC. And we'll see if they meet at a perpendicular. Alright, I'm going to be smarter this time. I'm going to go ahead and label my stuff because that was a little tricky without labeling. I don't like doing that. My head gets confused sometimes. So this is x2 and x1, so I don't know why my 2's don't look very good, but there they are. Y2 is going to be 5. Oh my gosh, it's so much easier. Minus y1, which is 0, over x2, which is 4, minus a negative 2. Okay, so that's going to become 5 on top over, these become positive, which is 6. Okay, so 5 over 6. These two right here are not opposite reciprocals. So is this a rhombus? So our answer is not a rhombus. And the reason why is these do not show perpendicular diagonals. So essentially we're using slope, we're using distance formula to help us find this. Let's do one last one. I'm actually not going to make you take notes on it. I'm going to say that a couple of times. I'll even write it so you guys don't make a mistake. I'm just going to go over it with you guys, but you don't have to write notes on it. Okay? So, boom, ba-doom, ba-doom, ba-doom. So let's go ahead, and I'm going to pause this, and I'm going to write, don't need to write. Please watch and listen, but you do not need to write. Okay. So a kite is shown at the right. We don't use kites, so we're not doing that, but we're going to still be able to use this shape and it'll make sense. What's the most precise classification of the quadrilateral formed by connecting the midpoints? So we need to find the midpoints. We can find the midpoints of these, and we're just going to run through it real quick. So to find the midpoints, we first like to know our points, so we put them in, and then we can use the midpoint formula. So they're going to do the midpoint formula for all of these. Look at that. So here's the midpoint formula. They plug it in, found negative 2, 2, and they graph it. And the next one, and the next one, and the next one. See why we're not writing this one down? Okay, so we got 4 midpoints. It's a lot of work. A lot of work right there. And they plot all 4 points and connect it. Now we're looking at this picture, and we're saying, yeah, this looks like it could be a rectangle. We actually know for sure that these are 90 degrees in here. We know these are 90s because, well, these slopes are perpendicular. So we actually know we have 90, and we can actually count these, and we could show that their sides are, opposite sides are congruent. So this is a rectangle already by virtue, but let's go ahead and just see what they write. So they drew the diagram. Step 3, we're going to classify it, use the definition of distance on a number line. So they're just going to count, and they get 6 for AB, 4 for BC, 6 for CD, and 4 for DA. So opposite sides are congruent, so we know it's a parallelogram. And then we know that their horizontal and vertical lines create right angles, so we know this is a rectangle. So again, this is kind of what we're going to be doing tomorrow. It takes a while. We're not going to be doing a ton of problems, like I said. So it is very important. I'm going to leave it with this. Not that, sorry, wrong thing. We're going to leave it with this. These right here are the key. We need to know distance, midpoint, and slope, and be able to utilize it. Okay, if we know our properties, we should be able to figure out what to do. Okay? All right, guys, this is me signing off. I'm out of here. Hasta luego. Goodbye.